Hi, today we're going to talk about 5.5 irrigation methods. Take a moment and check out the enduring understanding, look at the learning objectives, pause the video and review the essential knowledge as you set up your Cornell notes. So irrigation is withdrawing water for use in agriculture. And in the United States, we use fresh water for a variety of purposes. Predominantly, the biggest use of our fresh water is for thermoelectric power, which is generating electricity. However, this water is not used up, and it is still, this water, once we use this 45% of the water, we pump it back into the river or the lake where we took it. We cool it off first, and then we pump it back so it is used, it can be used by other organisms or for whatever purpose in the ecosystem. This irrigation accounts for 32% of our use of fresh water, but this water is actually not returned. So globally, we use about 10% of the withdrawal. When we pull up the water, take up the water from its source, 10% of it is for municipal uses, and that means in the home. So all the showering, the cooking, the cleaning, everything, drinking water, all of that, 10% of withdrawal of fresh water globally. 20% of it is for industrial purposes, for manufacturing, any type of factory. And the remaining 70% is used for agricultural purposes. So we are taking the water up from either a lake, a river, or from the groundwater, which is called an aquifer. And now I'm going to discuss a little bit review about what an aquifer is. So this is an oversimplification. But an aquifer is just another word for groundwater. It is the water that is stored in the spaces beneath the Earth's surface. It's stored in the spaces, the pores between the soil particles. So this is an oversimplification because it is not this clear. But the aquifer is this floating water in these pores, but the water table is the top of the aquifer. So the water table can be at different heights, and it can rise and fall based on water levels. So if it is an exceptionally dry year, the water table may fall. If the water is being overused, the water table may fall. If it is an exceptionally rainy summer, the water table may rise close to or near the surface of the earth. Now, if a farmer was coming in and wanted to access some of this water, all they would simply need to do is to dig a well and pump the water up. So this is aquifer, just basic information. Now there's a little bit more information that I want to provide. So now that you have that, here's again the water table. Now we have two types of aquifers. We have an unconfined aquifer and a confined aquifer. An unconfined aquifer is an aquifer where the water table is not covered up by rock or clay. In other words, it's covered up by porous soil. So the water can now, once it rains, the water can infiltrate. And this is our unconfined aquifer. It is easily accessible. But now we have a layer of clay, or it could be a layer of impermeable rock, where we can't actually access that unless we dig a well through that clay, through that rock. Now in this situation, this is considered an artesian well, and I don't really know how artesian wells, I don't really think that they show up. They might show up on some multiple choice questions. I don't really think that they're showing up. But the reason this is an artesian well is because it's going to flow on its own. There is pressure built up here because the level of the artesian well is beneath the top level of this confined aquifer. So this water here is pressing down, it's providing pressure, and it's the only place it can go is up through this artesian well. So this well will constantly flow. If you dig an artesian well into a confined aquifer, it will flow naturally. There are also artesian wells that do flow naturally, and some of the bottled water that we get from certain sources can be from artesian wells. Now, when water goes back or infiltrates back into the soil to fill the aquifer up again, that is called recharge. So recharge is just the infiltration of the water through this soil. A confined aquifer is going to take a lot longer to recharge because it can only recharge from this area here or through this clay. And as we've learned before, clay is almost it's very impermeable. It takes a very long time for water to go through it. The largest aquifer that we have in the United States, and in fact probably the largest in the world, is the Ogallala Aquifer, and it covers, it touches 7 states, and we have, most notably it's under the state of Nebraska, but we have a lot of these other states have access to this water, and a lot of these other states are very big on agriculture, and agriculture is one of their major industries. A lot of these states are producing a lot of the food products for the rest of the country. So this is a case of tragedy of the commons, where the withdrawal of the water is at a faster rate than it can be recharged. So the Ogallala Aquifer is actually depleting. Now, why is that a problem? Well, let me show you. So if we over withdraw, let's just say we have typical homeowner that has their well, and we have a farmer that comes in and wants to dig this super deep well. Well, this homeowner and this farmer can both get the water, but the farmer has maybe more money and they can dig a deeper well. So what happens over time? The farmer will over withdraw the water. So this is the normal situation, this is the over withdrawal, and the farmer is over pumping. And what we get is this cone of depression. It's kind of like if you've ever observed the drinking of a milkshake, and you drink the milkshake and there's this little cone when you're sucking up through the straw. That's kind of the same thing that's happening here. But now this homeowner doesn't have any access to water. But another thing can happen. The water is buoyant, and it can actually hold up the ground, the soil. And if you move this water out of there, it is not pushing up as much anymore. So the water table can be lowered, but also you can get subsidence. So in other words, because the water is not pushing up, this house could fall down, and that can lead to property damage. So subsidence is if you've ever heard of like a sinkhole, or you've seen like in the news where like a car or a house is swallowed up by a hole in the ground. That's a sinkhole. And oftentimes, especially in rural areas, it is because of over withdrawal from an aquifer. When you have this subsidence and property damage, it is expensive. But when you lower the water table, another thing can happen. Nearby wells will run dry. Not only just homeowners, but any well that is not extending down to the water table will not be able to withdraw water from that well. And that, in turn, over time can lower crop yields and produce less money for farmers. But another thing happens. In a normal situation, the water is pushing up to hold the soil in place, but if you're in a coastal area, it's also pushing out towards the sea. So the salt water is pushing in, the fresh water is pushing out. So maybe in like parts of Long Island, parts of upstate, coastal areas, parts of New Jersey, you have salt water that will push in because there is a lot of pressure built up in the ocean. There's a lot of water. There's a lot of water in the groundwater. So there is pressure, and this area, like we couldn't withdraw water from right here. But now if this farmer withdraws water, there's less pressure from the fresh water and there's more pressure from the salt water. And what happens over time is you can get saltwater intrusion. And the salt water builds up pressure and pushes into that fresh water. And now this farmer that pumped up too much water, it's basically their fault. Not just their fault, it could be other farmers' faults. But for over withdrawing, you now have less pressure to keep the salt water out. This saltwater intrusion will now enter the aquifer, and it will contaminate your groundwater. So this is very difficult to remedy. It is very difficult. You have to wait for this aquifer to recharge, and then you have to wait for it to eventually equilibrate, which could take many years, up to hundreds of years or more. And the problem with this, and the problem with over withdrawal of water, is an aquifer is not really like a sponge. I can take a sponge, squeeze it out, boom, done. Let go of it, and I could soak up water again. Essentially, when you're over withdrawing, it's like squeezing out a sponge, but that sponge is not going to just fill up right away. It takes a long time, and sometimes the aquifers can never be recharged. So this is a major concern, especially when we're talking about the over withdrawal of water from the Ogallala aquifer. Now, when we contaminate this salt water, we are definitely reducing also any sort of producers, plants that will be relying on this groundwater as well. And that can lead to biodiversity loss. So there are many impacts of irrigation. The purpose of irrigation is to deliver water. Now I'll talk about the different types of irrigation and their overall efficiency. So the first type we're going to mention is flood irrigation. That's when you flood the entire field. It's 80% efficient, which means 80% of that water is actually making it to the crops that it is intended to reach. 20% of it is lost to evaporation. Furrow irrigation is when you dig giant trenches in between the rows, and it's not very efficient. Only 65% of that actually makes it to the plants. 35% of it is evaporating and lost. Spray irrigation is slightly more. It is around 75% efficient, and 25%, or more could be evaporating. And the most efficient form of irrigation is drip irrigation, and that's where you put in a bunch of little tubes, and you basically have tubes running near the stems or roots of the plants, so it is almost directly applied to the roots. Now, if you ever have any, if you go to any parks, a lot of super fancy parks where it's completely landscaped, you'll see little water tubes in there, and that's drip irrigation, what they're using. Now, flood irrigation can lead to waterlogging. In addition, so can furrow irrigation as well. But this waterlogging, the problem with the waterlogging is it can destroy the crops because the roots become saturated and become submerged in water, and they cannot obtain oxygen. So they get what is called root rot, and that's where they will eventually die, because they will rot and decompose. So this crop destruction will also cost money. Now, I didn't put an arrow from the furrow irrigation because it would get all mixed up in there. So furrow irrigation can also contribute to waterlogging. However, both of these can contribute to soil salinization. And soil salinization is the soil becoming saltier. Here's what happens. You add this water. If most of it or a lot of it is evaporating, the water that we're adding is not pure water. The water that comes out of our sink has minerals in it. It has tiny amounts of salt in it. Even though it's fresh water, there is still a little bit of salt. So over time, if I'm constantly adding this water from this source, the water will evaporate. The pure H2O is evaporating, leaving behind all of the minerals. And some of these minerals are sodium chloride, and eventually you can have salt buildup on your crops. And once the soil is salinized, it is very difficult to remedy that or to remediate that. The soil will degrade, and that can lead to biodiversity loss. It can also lead to a loss of income to farmers. Now, one way to remedy this soil salinization is by rinsing it with fresh water. And another way to remedy that would be to install a drip irrigation system. Finally, you could try to, flood the fields when it is times when the evaporation will be lower, like at night. This is not really practical. One way that you could remedy the waterlogging and prevent the water waterlogging is by aerating the soil, and maybe not adding as much water, or letting the soil dry out before you apply more water. So spray irrigation requires energy to pump the water, which requires the consumption of fossil fuels, the combustion of fossil fuels to generate that electricity, which can contribute to climate change because of the release of carbon dioxide, and that can lead to biodiversity loss. Also, it's expensive for this irrigation to spray it, because you have to invest in the equipment, and also you have to transport the water to the field. You have to move these sprinklers around. It's also very expensive to set up a drip irrigation system. However, in the long run, the drip irrigation system will be very cost effective, because in the long run it will actually prevent environmental degradation. The drip irrigation results in very little water evaporation, which can increase your profits over time after you've recouped the initial expense. Now, there was a lot of information. I hope that it was informative. What I would like you to do is practice. Propose a solution to remediate soil salinization. Again, remediate means to remedy, to fix. Describe a drawback to the solution you proposed. There was a lot of information. I thank you very much for your attention, and I will see you soon.